This will be a very short lesson. Inequalities. The key to graphing inequalities, unlike equations, is understanding that there's infinitely many solutions to a two-variable inequality. So there's a couple things that we need to know. Greater than and less than. When we graph a greater than or less than inequality, the line will be dashed, because any point on that line will not be a solution. So what happens if it's greater than or equal to or less than or equal to? Well, if that's the case, then it's a solid line. Why? Because on that line, those are parts of the solution. Now, on a different note, greater than or equal to is going to get an up arrow. Less than or equal to will get a down arrow. Why? Because if it's greater than or equal to, we shade above. That shows all of our solutions. If it's down, we shade, or if it's shaded below, then every solution below that line is part of my solution set for inequalities. So make sure you have this written down, and then we're going to do 4 examples very, very quickly. Because this isn't necessarily a hard lesson for the video, but I want you to do a lot of practice with me. So you have that written down, so watch what happens. Let's see if I can shrink up the screen a little bit and get these all on here. So this solution right here is to x plus y equals 20. We're going to be graphing this solution where a point's at 40, a point's at 30. We're going to do this 4 times. Okay. Let's see if I can make it one smaller so that we can get all these on here. There we go. Okay. So it's a little smaller, but bear with me. So graph the solution set of x plus y is less than or equal to 20. Well, first off, I'm going to put where I know my points are on this immediately. So that way I know that I'm graphing the same graph over and over and over. Because it's going to be the same graph with some small tweaks. So this is less than or equal to. That tells me 2 things immediately. Because it's equal to, less than or equal to, I know that I am having a solid line. The less than tells me to shade below. So I draw an arrow above and below my line. Notice how it's a vertical arrow, it's following my y-axis. That tells me what to shade. And you can't really see the green, so let's throw it away. I hit a window, whatever. So I shade below. What does that mean? Anywhere in that shading is a solution to this inequality, including what's on that line. Well, this one says x plus y is less than. So not equal to, just less than. That means it's dashed, because that line does not include my answers. So I make an arrow that follows the y-intercept above, below. It's less than, we shade below. Everything below that. This is at 20, negative 10. 20, negative 10 is absolutely less than 20. Because 20 plus negative 10 is 10. That's less than 20. That's a solution. So here, this is greater than or equal to. Immediately, I know that if it's greater than or equal to, it's a solid line. My thumb was in the way. Not the best of lines, guys. Then I can follow it right along. Boom, up and down. It's above because it's greater than. So when I shade above. Pretty easy. This is just greater than, not equal to. So that means we have a dashed. Again, I go to my y-axis, I draw it up and down. It's greater, which means shade above. All of these are solutions. All of those are solutions. If you can understand that, I can get everything else in class. You will have some Google classwork to do at home, but this is the basic stuff of what we need to understand. Got it? Good. I'll see you in class.